Well, this is Dr. K. Sirish Kumar working as Associate Professor of Chemistry, St. Peter's Engineering College. So, today my topic is steps involved in treatment of potable water. Basically, the municipality people will supply the river water to us. Whatever the river water which is being supplied by the municipality to us contains several impurities in it, including the floating matter, suspended particles, aerated compounds, finely divided particles, and the pathogenic bacteria. So, before supplying the water to us, they have to ensure the complete removal of all these impurities from the water. Otherwise, these impurities, if present in the water, leads to hazard effects on the human beings. Now, let us discuss what are the steps involved in treatment of potable water. That is, what are the steps which are being carried out by the municipality people to convert the impure water into the pure water. The first step is screening. The first step is screening, right? The screening method or screening step especially used to remove all the floating matter present in the water. Basically, the floating matter present in the water includes leaves will be part of it, leaves, plastic is a part of it, plastic, and any other floating matter. The wood will be a part of it, right? Now, in order to remove the floating matter which is present in the raw water, this particular screening is being used. Now, in the screening process, the raw water is passed through the wire mesh, and the size of the or pore size of the wire mesh are designed in such a manner that whatever the floating matter which is present in the water will be retained on this wire mesh. Now, whatever the water which is coming out from this wire mesh will not contains the floating matter, because whatever the floating matter which is present is being retained on this wire mesh. So, this is about the screening process. The screening is especially used to remove the floating matter present in the water. Now, let us move on to the second step. The second step is aeration. And this particular method involves the removal of aerated compounds such as carbon dioxide and ammonia from the water. So, basically, what happens if carbon dioxide and ammonia are present in the water? So, if the carbon dioxide is present in the water, it reacts with water and converts to carbonic acid. That is, it makes the water acidic. And if the ammonia is present in the water, it reacts with the water molecules and converts to ammonium hydroxide, which makes the water alkaline or basic. Now, as per the specification of potable water, the water should not be either acidic nor basic. It should be around 6.5 to 8.5 pH. It should not be acidic. If the water is acidic in nature, then the heavy metals like arsenic, lead, manganese will be part of it, which leads to hazardous effect on the health of the human beings. On the other hand, if the water is basic in nature or alkaline in nature, then the very bitter taste, it will give the very bitter taste to the water, which is not drinkable. So, that is the reason whatever the carbon dioxide which is converting the water into the acidic nature and ammonia which is converting the water into the basic nature is to be removed. So, for that we have to carry out the deaeration process. Means we have to remove all the aerated compounds. What are the aerated compounds? Aerated compounds are basically the gases. So, these the carbon dioxide and the ammonia are the gases. Now, we are removing these gases which are responsible for increasing the acidity and basicity of the water. Now, what we need to do is the water containing gases such as carbon dioxide, ammonia, etc. should be passed inside this chamber, deaerated chamber. This is deaerated chamber. We have to pass into the deaerated chamber. Now this deaerated chamber contains the water, and the water contains the carbon dioxide and the ammonia gas, right? Right. Now what happens is, whenever we are passing the same carbon dioxide and ammonia containing water, or we have to pass the carbon dioxide and ammonia. We have to pass the carbon dioxide, ammonia into the water containing the same carbon dioxide and ammonia. Now, whenever we are passing the carbon dioxide and ammonia gas into the water containing carbon dioxide and ammonia, now what happens is, whatever the carbon dioxide and ammonia is there, they will be escaping out. Now, what is this method? So, in order to remove the aerated compounds, in order to remove the carbon dioxide and ammonia, which are responsible for increasing the acidity and basicity of the water molecule, we are passing the same carbon dioxide and ammonia. What is this process? In order to simplify this, for example, let us say that the classroom capacity is 100 members. For sitting, 100 members capacity classroom is there. If we force 500 members to sit in the same classroom, whose capacity is only 100 members, what will happen? The students will feel suffocated, right? The students will feel suffocated. When they feel suffocated, they want to run away, they want to escape out from the classroom. The similar thing is happening here. Let us say that in the water, carbon dioxide and ammonia are 100 carbon dioxide and 100 ammonia are present, just like the 100 members capacity classroom, 100 members classroom, right? Now we are passing the carbon dioxide and ammonia. Let us say that we are passing 500 carbon dioxide and ammonia into the water containing 100 carbon dioxide and ammonia, but the capacity of this is only 100. Now whenever we are passing 500 into it, so totally it becomes 600. So 600 students cannot be sitting in the class whose capacity is only 100. In the similar fashion, actually the capacity of this is only 100, but whenever we are passing the 500 carbon dioxide and ammonia molecules into the water molecules containing the carbon dioxide and ammonia, then what happens is they will suffocated and they will escape out from the water. Just like the 100 members capacity room, 500 members are letting inside it. It is not that easy. So all will feel suffocated and they will run away. In the similar fashion, whenever we are supplying more 500 to the 100 carbon dioxide and ammonia, they will feel suffocated, because actually its accommodation is only 100, but here 600 we are letting in. So totally what happens is all the carbon dioxide ammonia molecules which are responsible for increasing the acidity and basicity will run away or escape. So by this process we can remove the aerated compounds such as carbon dioxide and ammonia. This is about aeration. Now let us move on to the next process which is carried out by the municipality, that is sedimentation process. The sedimentation process is basically used to remove the heavier particles present in the water. So what we need to do is we have to feed the water inside the sedimentation tank, and the heavier particles are present, right, in this. And we have to keep this water stagnant for 2 to 6 hours. Whenever we are keeping this water stagnant for 2 to 6 hours, under the influence of the gravity, whatever the heavier particles which are present in the water will settle down as the sediments. Since this process is facilitating the conversion of heavier particles into the sediments, this process is called as sedimentation process. So with the help of sedimentation process, we can remove the heavier particles present in the water. So simply what we need to do is we have to pass the water into the sedimentation tank, and we have to keep it stagnant, remained undisturbed for 2 to 6 hours, and under the influence of the gravity, whatever the heavier particles which are present in the water will come and settle down. So this is about the sedimentation process. The next operation which is carried out by the municipality people is coagulation. Now, with the help of the sedimentation, we could remove the heavier particles present in the water. Heavier particles present in the water. Now, what about the lighter particles? What about the finely divided particles? Right? So, under the influence of the gravity, the heavier particles are coming and settling down, but the lighter particles cannot come and settle down under the influence of the gravity. So, what we need to do? We have to convert the lighter particles into heavier particles. Once the lighter particles are converted into the heavier particles, they will come and settle down under the influence of the gravity. So, this is the technique which is being used in the coagulation method, right? So, and this coagulation method involves the usage of the chemicals called as coagulants. This coagulants will convert the lighter particles into the heavier particles. The coagulants. One such example of the coagulant is aluminium sulfate. Now, there is no need to remember. There is no need to murmur or whatever. So, for example, if we take the aluminium sulfate, right? Just now I said that aluminium sulfate. Aluminium sulfate is a coagulant, right? There is no need to buttify the molecular formula of the molecules. In the aluminium sulfate, aluminium is the cation and sulfate is the anion, right? And it is trivalent cation and it is bivalent anion. Now, whatever the superscript is there becomes subscript for the cation, whatever the superscript is there becomes subscript for the anion. So, now what we are going to get, aluminium sulfate, Al2SO4 taken thrice, Al2SO4 taken thrice, Al2SO4 taken thrice. So, this is the coagulant which is being used, and there is no need to buttify the molecular formula. Just to find out what is the cation in it and what is the anion in it. What the cation is Al plus 3 and anion is SO4 minus 2, and whatever the superscript of the anion becomes subscript for the cation, and whatever the superscript of the cation becomes a subscript for the anion. So, accordingly we got the molecular formula of aluminium sulfate, right? Now, what is the another chemical with which the aluminium sulfate will react? So, don't search for another chemical, because another chemical is there, because aluminium sulfate is introduced into the water. So, since the aluminium sulfate is introduced into the water, another chemical is water only. There is no need to search for the another chemical with which the aluminium sulfate could react. So, as it is introduced into the water, aluminium sulfate will react with the water. The second chemical is obviously the water. Right. Now, how many moles of water with which it react, aluminium sulfate? So, just in order to remember that, just what you need to do is just do this 3 into 2. So, 3 2s are 6. It reacts with 6 moles of water. Just for remembering purpose only, I am explaining like this. The 3 into 2, 6. Now, basically, the reaction is all about the combination of cation of one molecule with anion of another molecule, and anion of one molecule with the cation of another molecule. Now, what is the cation present in this? Aluminium is a cation. Aluminium is a cation. And what is the anion present in this? Sulfate is the anion. And when coming to the water, H plus OH minus. Now, as I said that the reaction is all about the combination of cation of one with the anion of the other one, and vice versa. So, what is the cation here? Al. So, Al react with OH minus. This is cation and this is anion. Now, what we are going to get? Al aluminium hydroxide, AlHO3, aluminium hydroxide. Why it is aluminium hydroxide is AlHO3? Because in this case, what is the cation? Aluminium is a cation. Al plus 3 is the cation, and OH minus 1. As I said that the superscript of the anion becomes subscript for the cation, and the superscript of the anion becomes cation becomes subscript for the cation. So that's the reason it is AlOH taken thrice. It should be AlOH taken thrice. And how many moles Al2 is there, no? So we can write 2 moles of this. 2 moles of this. Now what is left? What is left? Sulfate is left and H plus is left. So HSO4. HSO4 is possible. HSO4 will not exist, right? H2SO4, because H2SO4 is sulfuric acid. H2SO4. 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 Now how many moles? So totally 3 are there here. 3. So 3 moles of H2SO4. So 3 moles of H2SO4. So 3 moles of SO4, and yes, 3 moles of H2SO4. Now this is how we have to write the reaction, but don't buttify. Just remember that while writing the molecular formula of the molecule, just find out what is the cation present in the molecule, what is the anion present in the molecule, and cation is here Al plus 3 and anion is SO4 minus 2. And whatever the superscript is there on the anion becomes a subscript for the cation, and whatever the superscript of the cation becomes a subscript for the anion. This is how you have to remember. And how to remember how many moles of, how many molecules of water is required? 3 into 2. 3 into 2. And whenever the aluminium is reacting with the OH minus, because it is positive, and this is minus, negative. Why we are getting AlOH taken 3? Because Al plus 3 is there and OH minus 1 is there. This 1 becomes a subscript for this, and this 3 becomes subscript for this. So aluminium hydroxide, right? Now this aluminium hydroxide which is formed is gummy in nature, is jelly in nature. It is jelly in nature or gummy in nature. Now what happens is, once the aluminum hydroxide is formed inside the water, now it combines 10-15 lighter particles and convert into the heavier particle. It combines another molecule of aluminum hydroxide, combines another 10-15 molecules of lighter molecules and converts them into the heavier particles. So in this manner, all the lighter particles are converted into the heavier particles. Once all the lighter particles are converted into the heavier particles, obviously under the influence of the gravity, they will come and settle down at the bottom of the container in which the water is taken, right? So just because aluminum hydroxide is jelly in nature, so what it is doing, it is combining 10-15 lighter particles into a big or heavier particle. So it is combining 10-15 lighter particles into a heavier particle, another 10-15 lighter particles into a heavier particle, and another 10-15 lighter particles into the heavier particle, by which the lighter particles are converting into the heavier particles. Once the lighter particles are converted into the heavier particles under the influence of the gravity, they will come and settle down at the bottom, right? So this is about coagulation. Now see, with the help of the first step, that is what is that first step? Screening. We could remove the floating matter present in the water. And second step, aeration. We could remove the aerated compounds, that is gases, from the water. And next step is sedimentation. We could remove heavy particles from the water. And the last step which we have discussed, that is coagulation. We could remove all the finely divided particles from the water. Now all these are suspended at the bottom, or not suspended, actually they are settling at the bottom. So since they are settling at the bottom, what we need to do is, the water now is a combination of liquid water and solidus material. Now we have to, what we need to do, we have to filter this solidus material which has been obtained during the sedimentation and coagulation, which is settling down at the bottom of the water. So for this we need to carry out the filtration process. So the water containing sediments which are settling at the bottom of the water should be passed initially through the fine sand layer. So most of the sediments will be trapped under the influence of the fine sand layer, because the fine sand layer is very finest, so that the sediments which are present in the water are being trapped. And if at all they are all are not trapped, let us say that 90% have been trapped. The remaining 5% will be trapped in the coarse sand layer. The coarse sand layer means the size of the sand is little bit bigger when compared to the fine sand layer. So let us say that till here 90% of the 90% of the particles, the sediments have been trapped. Until here 95% of sediments have been trapped. Now in order to ensure the complete removal of the sediments present in the water, what we need to do is we have to pass through the gravels layer. Gravels means stones. So once it is passed through the stones, almost 100% of the sediments are being removed from the water. Now the water is free of the sediments. Now the water is free of all the floating matter, sediments. Sediments means the heavier particles, finely divided particles, everything is being removed. Now what is left? Only one thing is left in the water. What is that? Pathogenic bacteria. Right. Now what is disinfection? Disinfection is the process of killing the pathogenic bacteria present in the water. Now what do you mean by pathogenic bacteria? Pathogenic bacteria means the bacteria which is responsible for the diseases. Is called as pathogenic bacteria, and the process of killing this particular pathogenic bacteria is called as disinfection. And disinfection can be carried out by three ways. The one is ozonization, second one is chlorination, and third one is by the addition of bleaching powder. Now let us see one by one. The first one is ozonization. So ozonization involves the addition of ozone to the water, and the ozone is not affinity towards the water, so it won't react with the water. Instead it will dissociate in the water. O3 dissociates as O2 plus single oxygen. Single oxygen is nascent oxygen. And nascent oxygen is a powerful disinfectant. Since it is powerful disinfectant, it kills the pathogenic bacteria present in the water. So this is all about the ozonization process of killing the pathogenic bacteria. But this particular ozonization is not widely used. The reason behind it is expensive method. So that is the reason it is not widely used. The next disinfection method is chlorination. Next disinfection method is chlorination. Now what we need to do is we have to pass the chlorine gas into the water. And the chlorine gas is affinity towards the water molecules. Since the chlorine is affinity towards the water molecules, the chlorine will react with the water molecules. Cl2 plus H2O gives rise to. Now let us see. Just in order to simplify the reaction, I am elaborating the structure as Cl plus HOH. Now just what you need to do is combine this HCl and combine this HOCl. Now what is the product? One is HOCl and the second one is HCl. Now this HOCl is hypochlorous acid, and it is the powerful disinfectant which kills the pathogenic bacteria. So the chlorination can be achieved directly by adding the chlorine gas into the water, or we can go with another method also. That is, we can add the chlorine and ammonia in stoichiometric ratio. Now, whenever it is done, just elaborating the structure, Cl, Cl, NH2, Cl, NH2, Cl. Now, NH2, not Cl, NH2, H, no, just elaborating the structure, nothing I am doing. I am just elaborating the structure of Cl2 as Cl, Cl and NH2, H. NH2, H. Now, what happens? The one product is NH2Cl, another product is HCl. Another product is HCl. So, what we are getting? We are getting NH2Cl, which is chloramine, and HCl. This is chloramine. Chloramine. Now, whatever the chloramine which is formed, whenever the chlorine and ammonia gas are passed, chloramine, NH2Cl, reacts with water, HOH, reacts with water, and just now what happens? Just what is the disinfectant which you got in the previous case? HOCl, powerful disinfectant. What is that? Hypochlorous acid. The same disinfectant is going to be formed here, like this HOCl, that is disinfectant, and NH2 plus H, NH2 plus H, NH3. HOCl is disinfectant. Now, the chlorination can be achieved by directly adding the chlorine gas to the water, or we can achieve by adding the chlorine gas and ammonia gas in the stoichiometric ratio to the water. Once they are added, initially the chloramine is formed, and this chloramine is reacting with the water molecules, resulting in the formation of hypochlorous acid, which is the powerful disinfectant which kills the pathogenic bacteria present in the water. The last technique is bleaching powder. Last technique is bleaching powder. By the addition of bleaching powder. Bleaching powder. Bleaching powder. So, bleaching powder is calcium chloroxylate. So, see here, the formula of bleaching powder is CaOCl taken twice, right. Now, in this bleaching powder, in this bleaching powder chemical, as two OCLs are present, now what could be the disinfectant which is going to be resulted? HOCl, because OCl is present, so HOCl will be the disinfectant. Now, as two OCLs are present, how many HOCLs can be formed? Two HOCLs can be formed. Now, for converting the OCl to the HOCl, 2 OCl to the 2 HOCl, what it needs? 2 hydrogens is needed. So, 2 hydrogens are needed. So, what is the source of those 2 hydrogens? The source of those 2 hydrogens is 2 moles of water molecule. So, in this manner you have to remember, that is, this particular bleaching powder reacts with 2 moles of water molecule. Why? Because here 2 OCLs are there. So, as 2 OCLs are there, there is a possibility of getting 2 HOCLs. 2 HOCLs means disinfectant which kills the pathogenic bacteria. And for the 2 OCLs, what are required for converting into 2 HOCLs? 2 hydrogens are required, right. Now, 2 hydrogens are a part of which molecules? Water molecules. So, that is the reason it reacts with 2 water molecules. So, in this manner you have to remember, but don't buttify as 2 water molecules, 2 water molecules, 2 water molecules. So, it needs 2 HOCl, that is the reason it reacts with 2 water molecules. So, just I am elaborating the structure as COCl, OCl plus HOH, HOH. Just I am elaborating the structure instead of this CaOCl, OCl plus HOH, HOH. Now, from this it is easy, see, well, this is one HOCl and this is another HOCl. Now from this, what you are going to get? We are going to get 2 HOCl, and what is left? 1 calcium is left, Ca, and 2 hydroxyl are left, CaOH taken twice, which is calcium hydroxide, and 2 HOCl is powerful disinfectant, right? So these are the steps involved in treatment of potable water. The first one is screening, which removes all the floating matter present in the water. The second step is aeration, which removes all the aerated components present in the water. Third step is sedimentation, which removes all the heavier particles present in the water. Next is coagulation, which removes all the lighter particles present in the water. Second one, next is filtration process. Filtration process will remove all the sediments which are settling down at the bottom under the influence of the gravity from the water. And the disinfection removes all the pathogenic bacteria from the water. And among the three, the one is the ozonization, chlorination, and the bleaching powder. The bleaching powder is most widely used because the bleaching powder is solid, and handling the solids is very easy when compared to the handling the gases in the previous cases. And the ozonization is not very much widely used. The reason is it is expensive process. I hope you understood this particular steps involved in treatment of potable water. In the next video, I will come up with the next important topic. Thank you.